Hi everyone. Today let's discuss about one of the Facebook phone interview question. Average sum of descendants equal to node value. So let us first go through the question. So the question is very much similar to maximum average subtree problem. So uh, we need to count the average of the each subtree. Okay. So from here the actual question starts. Traverse each node in the tree and get the average from the subtree. The average should then be equal to the current node value. If this property is satisfied for all the nodes, then return true, else return false. That's the question. Let us take a few examples and understand it. Let us say we have 2, 3, and then 2 plus 3, 5, 5 plus 4, 9. Yeah. So let us say we have a tree like this. At each and every node, let us see the property is valid or not. So at 3, what is the average of the subtree within of the tree? So the average would be sum of all the nodes by number of nodes. Sum of the nodes in the subtree of 3 is 1. Sum is 3 and the number of nodes is 1. So the average is 3, which is equal to node value. So property is valid here. Similarly, sum is 4 here and value number of nodes in the subtree of 4 is 1, which is again property is valid here. For 2, what is the sum? 2 plus 3 plus 4, 7. 2 plus 3, 4 plus 4, 9. Divided by number of nodes in the subtree of 2 is 3. So it is 3. 2 is not equal to 3, so the property is not valid here. So we should return false in this case. Right? So let us take one more example. 3, 3, and then 3. In this case, the property is valid for 3 because 3 by 1 is average. Here also it is valid. Here, sum of all the nodes in the subtree of 3 is 3 plus 3 plus 3, 9. Divided by number of nodes is 3, which is equal to the node value. So property is valid here. So property is valid on each and every node. So we should return true here in this case. Right? Let us take one last example. 2. Yeah. In this case, property is valid at 2, 4 because 2 by 1 is average, 4 by 1 is average. At 3, sum is 3 plus 2 plus 4, 9 divided by number of nodes is 3, which is 3. So the property is valid at 3 as well. So here also the answer should be 3. Now I hope everyone understood the question. So I would suggest you guys to pause the video and think of different approaches to solve the problem. Okay. So at every node, how can we calculate the average? That's what we need to calculate so that we know whether the property is valid at that node. So we also know that average equal to sum of nodes divided by number of nodes, right? Number of nodes. So what if we call left subtree and get the sum of the nodes within the left subtree and the number of nodes, and at the same time call the right subtree as well and then get the sum and number of nodes and then calculate the average at a particular node. Now, if at all the property is valid at a particular node, it should also be valid at every node. So, if at all the property is not valid at some node, we can just set a global variable as false and then return. And if at all the global variable is set as false, we can just break the uh, flow of the traversal and stop it. So in this way, if at all the global variable is which is by default initially set to true at the end of the traversal is still true, it means the property is valid at all the nodes, or else it is not valid at some node, right? So we are traversing every node only once, because let us do a pseudo implementation. So global flag initially set to true, and then we have check of root. This is the function, and then we need to get the sum comma number of nodes from check of root dot left, and then sum comma num1 num2 sum2 sum1. Before that, we can also do if root is double equal to null, break or return something like 0 comma 0. Check of root dot right. Now if root is double equal to null or flag is double equal to false, then return. No need of further doing any traversal. Now average equal to sum1 plus sum2 plus root dot value. This is the sum of all the nodes in this subtree, divided by 1. 1 is the node, root node, num1 plus num2. If this average is not equal to root dot value, what we need to do is flag equal to, we should set the flag equal to false, and then return finally we should also return a sum. So sum1 plus sum2 plus root dot value comma 1 plus num1 comma 2. So once you call the check for the root of the subtree, and then flag stores the answer. This is the pseudo implementation, guys, for implementing the given question, that checking the property, average property for every. So what is the time complexity of this approach? As you can see, we are only traversing the nodes only once. For all we are going at a view route, we will go to left, right, and then we are not doing any more traversal. So it is order of n, where n is number of nodes in tree. This is the time complexity. What would be the space complexity? So space complexity wise, we are not cloning the tree or modifying the existing tree or creating a global array or something. So it is still order of one uh, order of one space complexity. Or if you want to consider sum1 num1 and these variables into consideration, which are created for every node, we can say that order of 1 n is the space complexity, because for every node we are initializing sum1 num1 and sum2 num2, and we are initializing order of n times, where n is the number of nodes. So this is the time complexity and space complexity of the approach. So yeah, so now as the guy said, the problem is very much similar to maximum average substring problem. Let us try to implement our algorithm here so that we can know it works. No, so coming to this question, given the root of the binary tree, return the maximum average value to subtree. Answer within 10 power minus 5 of actual answer is accepted. Subtree is any node of the tree plus all its dependent average value is the sum of nodes. Very much similar to the question that we have solved just now. There we were checking the property, but here we need to calculate the maximum average. So how can we modify the existing algorithm to calculate the maximum average? Here, we just need to modify this one by, we just need to comment this out. We need to comment this one and then global answer equal to initially 0. We need to do something like answer equal to max of answer comma average. So this way, at every point, we are calculating the average and also updating the global variable of answer. So we can keep a global variable or take the answer in the function as well. Okay, let us try to implement it. So initially, let me keep a global variable as 0 and then I will create a calculate util with answer and then this answer. Now this gives us a vector of integer where the first element of the vector would be sum and second element would be the number of nodes, right? So 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 we have as we have calculated as we have already done the pseudocode, it would be easy for us to implement it. So I will first do if root is double equal to null, I will just return 0, 0. Then a1 equal to calculator answer. Similarly, you do it for the right subtree, calculate for the left subtree and the right subtree. Finally, the average at this point is equal to root value and then a1 of 0 plus a2 of 0 divided by 1 plus a1 of 1 plus a2 of 1 plus 0.0, so that I'm adding 0.0 at the denominator so that it will become a double. So if at all 1 by 2, if I do by integer division, it will become 0 in C++. So if at all I do 1 by 2.0, it will give me a double answer or average in the double data type. So now max of answer comma average and then return. Yeah. So we have written the code. Let me just run it. So here, okay, no data of turning in 0.0 because I said it's a vector of integers. So in the first example, it has false. Let me try the second example and then submit. Yeah. So the algorithm is working. Might be we are not doing good because we are returning vector of integers, but we can also improve it by uh, setting setting a variable by passing them as reference. But this is even more cleaner and simple to explain in interview. So I hope you enjoyed the video and got the approach on how to solve a tree average problem. Thank you.